We're starting now with example 6 from section 8.1, Systems of Linear Equations. Okay, we're to solve this system. Again, this is not one I naturally would go for substitution, but you can certainly do that. What I'm seeing is if I multiply the bottom one by -2, that would make that +6, and my y's will cancel. So -2 times 2x minus 3y equals -2 times 6. So I have -4x plus 6y equals -12. And now bring the top one down, 4x minus 6y equals 12. And when I add, that's 0, that's 0, and that's 0. Okay, well the variables are gone, but this is a true statement, not a false statement. So which result do you think this is? This is infinite solutions. And we can check by putting them in y equals mx plus b form, because let's see what happens. 4x minus 6y equals 12. -6y equals -4x plus 12. Divide by -6. Y equals 4/6, which would be 2/3 x. Divide 12 by -6 minus 2. So m is 2/3, b is -2. Does that look right? Okay, let's do the other one. 2x minus 3y equals 6. -3y equals -2x plus 6. Divide everything by -3. Y equals +2/3 x. 6 divided by -3, -2. M equals 2/3, B equals -2. So the lines are the same, which means the system of equations is consistent, and there are infinitely many solutions. And so here's another way we can write the solution in set notation. The set of all ordered pairs x and y such that, and let's describe them. We just use one of the equations. 4x minus 6y equals 12. In other words, we're saying any point that satisfies this is a solution. Or, of course, since they're the same, we could just use the other one, 2x minus 3y equals 6. So that's another way to describe the solution set. All right, what we have left are 3 application problems for systems of equations. So we first have to write a system of equations. That means we've got to have equation number 1 and equation number 2, and then we'll use substitution or elimination to solve. The length of a fence required to enclose a rectangular field is 3,000 meters. So if you're enclosing a field, is that area or perimeter? Yeah, that's perimeter. So the perimeter is 3,000 meters. And what's our equation for perimeter? 2 lengths plus 2 widths, right? So our first equation is 3,000 equals 2 lengths plus 2 widths. Well, what else do they tell us? What are the dimensions of the field if it's known that the difference between length and width is 50? So our other equation is the difference between length and width is 50. So this one I could rewrite as length equals 50 plus width, right? Solving for L, and now I can use substitution in the other equation. 3,000 equals 2L, but L is 50 plus W plus 2W. 3,000 equals 100 plus 2W plus 2W. So 2,900 equals 4W, and W equals 725. So our width is 725 meters, and our length, let's do it down here. L, we said, is 50 plus W, or 50 plus 725, or 775. So our length is 775 meters. So we use two equations. This is very similar to section 1.7, where we found an expression for one variable using the other. But now we're kind of doing the same thing using the two equations. Likewise, these two will seem somewhat familiar. Solution A is 50% acid, solution B is 80% acid. How much of each should be used to make 100 milliliters of a solution that's 68% acid? So I'm just going to let the letter A represent the milliliters of 50%, and B represent the milliliters of 80%. And we know if you take the first equation, says take the milliliters of 50% and add to it the milliliters of 80%, you better end up with 100 milliliters. Not 1,000, 100. 100 milliliters, because that's what they say you're supposed to have. That's one equation. The other one, we'll use the percentages of acid. So A is 50% times the milliliters of A plus 80% times the milliliters of B equals 68% times the milliliters of the total. This equation I can change for substitution and say that A equals 100 minus B and plug it in here. So 0.50 times 100 minus B plus 0.80 times B equals 68. Distribute 50 minus 0.50B plus 0.80B equals 68. This will be 0.30B, and 68 minus 50 is 18. And divide 18 by 0.3, and you get 60. So we need 60 milliliters of B, and since A is 100 minus B, we need 40 milliliters of A. My last mixture problem. A solution of pure antifreeze is mixed with water to make 65% antifreeze, a 65% antifreeze solution. How much of each should be used to make 70 liters? So let's let X be the liters of pure antifreeze, and let Y equal liters of water. And we know that's all they're mixing. They're mixing X plus Y, and they're getting 70 milliliters. So that's one equation. The other one, let's use percentage of antifreeze. How much percent antifreeze is pure antifreeze? It's 100% as a decimal, 1.00 or just 1. X plus what percent antifreeze is the water? 0. That might look funny, but that's what it is. It's 0%, 0.00 Y equals what percent is our solution? 0.65, and how much of that do we have? 70. Okay, so of course that's just 0. So we end up with 1.0x, or x, is equal to 0.65 times 70, which is 45.5. And we didn't even have to do the substitution, but we could have, right? We could have said that y equals x minus 70, but then we would multiply by 0, right? I kind of left that step out because of that term being 0 anyway, but we could have said y equals 70 minus x. And if you put 70 minus x right here and multiply by 0, it still goes away. So x is 45.5, and then the liters of water will be 70 minus 45.5, or 24.5. So we need 45.5 liters of pure antifreeze and 24.5 liters of